Hi! In this video, we will be making Freeverb as a pure data abstraction. Freeverb is a fairly popular reverb model. We will recreate it here with all its features, including one that has been left out in most implementations. First off, we'll start by retrieving Freeverb's original source code. Here it is a VST plugin, but we are only interested in the internals in the components folder. Inside revmodel.cpp, we can identify the main structure of Freeverb, shown here. For simplicity, only the left channel is presented here. And here it is with additional information found in tuning.h. We'll first look at this component, the LBCF, for low-pass feedback comb filter. These two files allow us to find the following diagram for the filter. If you're wondering what those Z's mean, they simply represent taking the signal one sample in the past here and m samples in the past here. If you're wondering why they are this way, they have something to do with something called the Z-transform, but we don't need to know that right now. The triangles here simply represent multiplication. Here we have D, the damping factor, and F, the feedback gain. This part here is a low-pass filter, and here is its frequency response. As you can see, when D gets closer to 1, the higher frequencies are less and less allowed through. This is to simulate the reflecting surfaces absorbing the energy of high-pitched sounds. The low-pass filter can be implemented on its own using a FXPer object, which stands for filter expression, like so. Now, there are more efficient ways to implement this filter in Puredata, but I find this one to be the easiest. Then, this part can be done with a delay line. We'll make the damping factor and feedback gain inlets so we can change them on the fly later. As for the delay, we'll make it an argument to the abstraction. Freeverb was originally written for a sample rate of 44.1 kHz, so we hardcode it here. And we convert the number of samples to milliseconds for the delay line. Now we can save this abstraction. Now let's have a look at this Allpass filter. Here is how it's implemented, and that gives the following diagram. And here it is implemented in Puredata. Here, the feedback is a constant 0.5. I think this filter is just used to add a few reflections in the reverb. Now, we have all we need to put it all together. Using tuning.h, we can fill in the delay values for the low-pass feedback comb filters and all-pass filters. Here, I have separated them in sub-patches for left and right channels for legibility. Now, all that is left to do is to add the feedback and damping logic and initialize them like so. But wait, how about that secret feature I told you about? Well, here it is. It's the freeze mode. We can simply add it like so. And there you have it, your very own Freeverb inside Puredata. I hope this video has been useful for you, and thanks for watching.